Okay, we're looking at all this information here. What we're going to do, we're going to define this function, and then after that, we'll work our way through the different questions here as they appear. We got all of them. Okay, yeah, that's all of them. All right, so I'm going to go to CAS. I'm going to close this because I don't want any variables or anything saved. I'm going to go to the calculator and I'm going to define it. So I'm going to define. I'll leave that as h of x just because my graphing means x. So h of x equals, now I'm going to type this in here, so negative 2.98 t squared, negative 2.98x squared, I'm dealing with x, not t, plus 30.6 plus 30.6 x plus 4.5 plus 4.5 given, now I put in my domain, 0 to 9.4, so 0, they're both inclusive. So this thing, x, that thing again, 9.4. So now that I've got that, oh, and this thing on CAS, if you want to find it, it is here. So control equals, and it's that one there. So at what height was the motion when it initially started? So I'm going to do that. Okay, so when it's initially started, that means h of 0. So 4.5 is initially 4.5 meters above the ground. From a safety perspective, you consider if the model rocket explodes at least 25 meters above the ground. Did the model rocket explode at a safe height? Explain your answer. So, how can we work that out? I'd be saying that we want to find 25 meters. Did it end up going above 25 meters? So, I'd be saying h of 9.4. I'm assuming, I don't know, that it's traveled for 9.4 seconds or 9.4 minutes. What does it tell us? Does it tell us what h? Motion modeled by this. It doesn't tell us. Okay, so I'm assuming at 9.4 seconds. Anyhow, 28. So yes, it is above that. So that tells me it traveled for 9.4 seconds before it exploded. So yes, it did explode at a safe height. What was the maximum height to the nearest meter that the model rocket was above the ground? Okay, so let's graph this. Can we do max? Is it f max? F max. Oh, that's interesting. H of x. Oops. Oh no, h of x, we want x. We want y. Let's see what this tells us. Well, it tells us the maximum happens there. So we could do h of, I'm going to take this, I'm going to copy and paste it into here. Let's see what we end up with. True. Okay, we want to solve for that, not solve, we want to say this. It's 83.035. How else can we check it? We'll graph it. So menu, home, graph, we're graphing h because we've defined it, because we're going to use it a few times. There it goes. Menu, analyze graph, window zoom. Let's set our zoom settings. So it's -1. Let's set this to 10 where it stays. Let's set this to -5, and let's set this to 100. There we have our graphs. Analyze graph, maximum 83.1. What does this tell us? What did the other thing tell us? 83.05. So let's have a look. To the nearest meter, so 83. If we have a look at this, it's also 83 meters. That's okay. All right. So for how many? So that's what we've got there. 83.83, 84, 83. For how many seconds corrected 2 decimal places was the model rocket at a height above 51 meters? We want a above 51 meters. Let's have a look. So we're going to plot 51, that's our height, and then we're going to measure for how long it is above that time. So intersection, whoops, between here and here, menu, intersection between here and here. So we're going from 8.41 back to 1.85. So it wants how many seconds? So we're just going to delete, we're just going to subtract it. 8.41 this every time. 8.41 minus 1.85. 1.85. And we end up with 6.56. So for 6.56 seconds, it was above a height of 51 meters. If you're wondering how I'm going between the windows, control right to go to the next one, control left to go to the other one. Okay, so that's it for that question. Next video, we'll have another question.